Hello everyone, I'm Albertas Gimbutas. Today I will present my side project that I'm still developing called Deadcode. It is a tool for finding and fixing unused Python code. My presentation consists out of four parts. Firstly, I will define what Deadcode is and tell a short story about how I started Deadcode. Secondly, I will describe several features of Deadcode including behavior tuning and automatic fixing. Thirdly, I will show how Deadcode package could be used. And finally, I'll compare two strategies of unused code detection. Let's begin with defining of the Deadcode. Deadcode for me is unused and no longer needed code that could and should be discarded, but it was never removed. This type of Deadcode creates technical debt because it consumes time and cognitive capacity whenever it has to be understood as part of a code base. Unused code has to be maintained as well. For example, when a dependency or Python version gets upgraded, unused code has to be updated as well. In addition, unused code might bring in unnecessary dependencies that might be outdated or have security vulnerabilities. So unused code is like those bad guys from the movie Matrix that are waiting to cause you trouble. Once I have bumped into this pull request that contained unused class. The author initially wanted to use it, but later on decided not to, and forgot to remove this class from the pull request. It made me wonder why this unused class was not detected by our linters, because we were using very strict linting rules with almost all rough rules enabled, but still this unused class was not detected. Removing unused code saves time, money, and reduces risk, so it would be excellent to detect it and remove automatically whenever it appears. However, it was not the case. So I started investigating. I have reviewed all rough rules and found out that rough has some rules only for locally unused code, and that consists only of small part of all existing unused code. And these rules were not able to detect that unused class in the pull request. So I started searching for other tools for that case and found another tool called Vultr. It is the most popular and capable linter for globally unused code detection. And it has a lot of GitHub stars. I tried using it, but I have bumped into several issues. The first issue was that it has provided a lot of false positives. Attributes of model in Django or typedict or schema were reported as unused names, even though these attributes have special meaning and they serve a purpose and they are used. Also, meta class and its options were reported as unused. Second issue was that there were no convenient options to tune out these false positives. I had to explicitly silence every single attribute by its name in order to remove those false positives from the vulture output. And whenever a new attribute is added, I had to add it to vulture configuration as well. That makes vulture not very convenient to use. It adds huge overhead. And in addition, vulture is only capable to find those unused code items, but you have to remove them manually yourself. That also adds additional overhead. So in my case, I decided that using vulture adds too much overhead and decided not to use it. This led me to creation of new tool. Initially, I thought that it would be possible to add some features to Vultr source code, but I have reviewed it and decided that it would require too significant refactoring, and my changes would not be accepted ever. So it was way easier to just start a new tool, and I created Deadcode. It is implemented in Python, and it is way easier to prototype uh, and move faster using Python. But eventually, this Deadcode tool might get integrated into Rough if feature set gets stable and this Deadcode package gets recognition. The Deadcode package has three main advantages. Firstly, it provides flexible behavior tuning options that allow to ignore code items in different ways. It allows to ignore code based on name, inheritance, or decorators used, and uh, part of a code expression could be ignored, a name, a body, or whole definition of it. Second benefit is that Deadcode provides more types of unused code, including removal of unused empty Python files. And third benefit is that Deadcode allows to automatically remove unused code. Let's review these three benefits into more detail. So, Deadcode provides options to fine-tune its behavior. Here we can see a class on the left, and definition, name, and body is marked in it. So Deadcode provides options to ignore each of these elements. You can ignore definition, name, or body based on class name, inheritance, or decorators used, and that applies for other expressions as well. So here on the right, you can see a simple Deadcode configuration that allows to tune out most of the false positives that I faced when using Vultr. You can ignore bodies of data classes. You can ignore bodies if class inherits from model, type dict, and schema, and it makes that code way more convenient to use. That code package provides more types of unused code, and these types could be ignored by line or per file, or completely. That code also provides fix option that will automatically remove unused code items. Before applying fix, you can see the change would that would be applied by using dry option. And that code will also remove empty Python files that are not using dollar naming if they're empty. Let's move to usage of Deadcode package. Deadcode can be installed using pip, simply by running pip install Deadcode, and you can run Deadcode CLI command by providing Python source files that have to be checked. Here you can see that a single foo.py file was checked, and you can see its content on the right. All unused code items are marked in purple, and you can see on the left that all those unused code items were detected and reported. And if --fix option is provided, those code items are automatically removed, and the output of that code command looks almost the same, but it includes one additional line that states that 7 unused code items were removed. And as you can see on the right, those code items are no longer present in the source code. It is also possible to see the diff before applying it. You just have to add --dry option, and you could fine tune the Deadcode behavior before applying automatic fixing to avoid removal of false positives. Also, it is a good idea to double check if a change is correct before removing code. Let's move to the last part of presentation, Let's compare two different strategies of unused code detection. Both Vultr and Deadcode uses abstract syntax tree to parse and analyze Python code. And it is hard to interpret this abstract syntax tree because only the names of the labels are provided without any association between those names. So definition and usage are not associated in any way in the abstract syntax tree. Let's consider Vultr strategy for unused code detection. Here we can see a code snippet on the right that defines a class and uses it. As a first step, Vultr would find all defined names. Those are foo and spam. As a second step, Vultr would detect all used names. On the fifth line, we can see that foo and spam names were used. And as a third step, Vultr would report the difference between defined and used name sets. And in this case, it's empty set. No findings are detected. Let's consider a little bit more sophisticated example. Here on the left, you can see two classes that have the same method called spam. As a first step, Vultr would detect three defined names that are foo, spam, and bar. And on the 9th and 10th lines, some of those names are used. As a second step, Vultr would detect used names that are foo, spam, and bar. And as a third step, it would report the difference between those two sets, and it is an empty set. Unused bar spam method will not be reported even though it should be. Let's consider another strategy used by the Deadcode package. It uses dot-separated paths to identify code items. And as a first step, defined name set would be created, which is foo, foo spam, bar, and bar spam. As a second step, all used names would be detected that are foo, foo spam, and bar. And as a third step, the difference between those two sets is found. And in this case, bar spam is detected. So unused bar spam method is correctly detected, but not in all cases this dot-separated path can be constructed. So Deadcode falls back to Vultr's strategy if match cannot be found. Hence, uncertain code items will not be reported by the Deadcode. I would like to conclude that Deadcode package prevents technical debt from appearing out of unused code. Thank you very much for listening. I appreciate your time. I would like to encourage you to try this Deadcode tool and to create issues in GitHub if you find any, and also buy me a coffee. I will fix one issue per cup of coffee.